Example 6 in Stat 101, Examples Class 5, using expected value to calculate the cost of damage after rain. The National Weather Service has provided a forecast of a 30% chance of rain in a catchment. A flood defence system near a factory is already at maximum capacity. There is a 50-50 chance of defence failing if it rains. If it rains, but the flood defence holds, the factory expects to suffer just 10k in damages. However, if it rains and the flood defence fails, they will suffer damages of 500,000. What are the expected damages suffered? Putting this information on a tree diagram will enable us to see the options available for our random variable in this case. First step of the tree diagram, is it going to rain, probability of rain, or probability of no rain? Probability of rain, 0.3, probability of no rain, therefore 0.7. 30% chance of rain, as shown in red there, so the probability that it's not going to rain will be the complement of that, that's our 70%, 0.7 in terms of probability. Second stage of the tree diagram, the flood defence holding or the flood defence failing. If it rains, the probability that it holds, 0.5. It tells us we have a 50-50 chance of defence failing if it rains. So the probability it holds will be 0.5 and the probability that it fails would be 0.5. Our 50-50 chance. Putting our damages on the tree diagram, chance of no rain, probability of no rain 0.7. There would be no damages expected to be suffered at that position on the tree diagram. So the expected damages of 0 in that case. If it rains and the flood defence holds, the expected damages $10,000. 10k, $10,000 in damages. However, if it rains and the flood defence fails, the damages are expected to be $500,000, 500k. Tree diagram now complete. We'll have a look at the expected damages suffered. Defining our random variable x in this case as the amount of damage suffered. Random variable x, let x be the amount of damage suffered. Remembering the formula from the formula sheet, Stat 101 formula sheet, our expected value of x is the sum of x times the individual probabilities, sum of x times PRx. We'll use a table to draw up these values to work out this expected value of x. The first column will be our values of x, the amount of damage suffered, what values can x possibly take. The second column will be the probability our random variable is equal to the little value x. And the third column for our x times its probability. Our values of x, what values can x possibly take? These are shown in red on the screen. X could be 0 in the chance of no rain. X could be $10,000 in the chance it rains and the flood defence holds. Or it could take the value 500,000 if it rains and the flood defence fails. These are the only three values x can take for our amount of damage suffered. The corresponding probabilities, picking these up from the tree diagram, probability of no rain, so the probability that x will be 0 is 0.7. The The probability x takes the value 10,000 is the probability of rain, that's 0.3, times the probability the flood defence holds, 0.5. 0.3 times 0.5, working out to be 0.15. The third case, probability of rain and the flood defence fails. So probability of rain at 0.3 multiplied by the probability that it fails of 0.5. 0.3 times 0.5 giving us 0.15. Moving on to the third column, multiplying our x value by its corresponding probability, 0 multiplied by 0.7 in the first case, leaving it at 0. 10,000 for the second case, multiplied by 0.15, working out at 1,500. And the last case, when x is 500,000, x times its probability, 500,000 times the 0.15, giving a value of 75,000, 75,000. In the formula, the expected value of x is the sum of the x's times their probability. Adding up this third column will give us that sum. We'll be adding 0 plus 1,500 plus 75,000, 75,000. The total coming to $76,500. The expected damages suffered, $76,500 in this case. Value we expect X to take in the long run. The expected damages suffered is $76,500, which is a cost to the company. And this is the end of example 6.